All right, we're going to talk about simplifying fractions using GCF and LCM today, right? Applications of that. And simplifying fractions is certainly one of the easiest ones that we've done. Now, if I give you this fraction 14/20ths, I'm sure that all of us are going to tell me that it is equal to 7/10. All right? And the question is why? All right? Now, I want to know, what did you divide? Here's the question. Did you divide by 2 in order to get your answer? Did you? Aha. No, you did not divide by 2. Mrs. Buster, what are you talking about? Yes, you did. 14 divided by 2 is 7. 20 divided by 2 is 10. But you divided by 2 over 2. And 2 over 2 we know is 1. My friend Mrs. Bailey used to teach in the junior school. She would call this the masked 1. Right? Like it was 1 in disguise. And in fact, that's true. Another way to look at this is if you take your 14/10ths and you break 14 up into its prime factors. Part of the prime factors, the ones that are like or matching, you know, this part of the fraction is equal to 1. So it's really 1 times 7 over 5. Which would be 7 over 5. This is a different fraction than altogether. Duh, I started with that. So, again, sometimes we say we're canceling out, right, a common factor in the numerator and denominator. But what you're really doing is you're dividing by that masked 1. All right, so if I want to reduce this fraction, right, and if the direction is, it would probably be, for me, it would be simplify, right? If you could read that at all, it says reduce. All right, my direction probably would be simplify, right? That would be my direction, simplify. And we've got 84 over 162. So again, you know, if I gave this to a third or fourth grader, they would divide them top and bottom by 2, get 42 over 81, and then you'd have to go, ugh, what goes into both of these? Man, this is horrible. And you might know that this is 3 times 14, this is 3 times 27, and so you can cancel out the mass 1 of 3's. And then you got to say, oh, it's 14/27. Is that simplified? And then you think for a while, and you may come up with the answer that it is, but you might not. I don't know. But if instead, all right, let's just get rid of this. If instead I did the factorizations of the numerator and denominator, and again, 12 times 7, so 12 is 2 times 3 really quickly. 162 is 81 times 2, so 81 is 3 to the 4th power. And I can cancel out common power 2 here, common power 3 here, or I'm canceling out 2 times 3 or 6. And now there's no other common primes to cancel out. I'm left with 14 over 3 times 3 times 3, which is 27. And since there's no common primes left, there's nothing left for me to cancel. Let me write this a little neater. Debatable. 14/27. And the question I pose before you is, how much fun is that? Really? That's so much fun. The answer is so much fun. Alright, so what's the GCF between those two? Alright, the hint is I canceled out a 2 and a 3. So the GCF, we should understand, is going to be 6. And if I found, right, 12, I know is going to come out to be 2 times 2 times 3. Okay, not my favorite thing. All right, and 162 we said was, what did we do? 2 times 81. And then 81 we know is going to be 3 to the 4th. Again, in common they've got 2 times 3. So their GCF is 6. And that is the thing that gets canceled out. If I stack them on top of each other, if it is a fraction, that's what gets canceled out. Alright, finding the GCF here between 420 and 462. I would probably do 42 times 10. 42 is 6 times 7. So this is going to be 2 times 3 times 7. And then 2 and 5. If you want to put these in order, you probably could. It seems pretty good. These things add up to 12, so 3 will go into here. How many times? 154. 3 goes into here, so I probably could have done, no, let's see, 3 doesn't go into this, it's 10. Alright, so this is 2 times 77. It's 77 is 7 times 11. So, I've got 2 times 3 times 7 times 11 over here. I've got 2 times 2 times 3 times 5 times 7. In common, they have a 2, a 3, and a 7 in common. So notice we didn't use this 2 times 5 or a factor of 10. We didn't use this factor of 11. But the GCF is going to be 2 times 3 times 7 or 42. So if I have the fraction 420 over 462, that's exactly what I'm going to be canceling out 2, a 3, and a 7. And so canceling out 2, a 3, and factor of 7, I canceled out 2 times 3 times 7 or 42. The GCF is what I canceled out. And all that was left is 2 times 5 or 10 over 11. Notice, I didn't have to do any division. I didn't have to divide them both by 2 and then by 3 and then by 7 or even by 42. All I did was cancel out. And so certainly that is going to be faster and better for us. So when I'm looking to simplify the fraction, right, one option is to divide. But number one, I can't divide 24 and 40. So, I mean, I can, but I would get a decimal number. And so all I really want to do is I want to cancel out the common primes. So if I look at it in terms of the factorization, right, and pause it if you need to write this down before I continue. But here's the factorization for 24, x squared y to the third z. 24 is 8 times 3, so 2 times 2 times 2 times 3. X was x squared, y to the third, z. And then 40, x, y, z to the third is 8 times 5, so 8 I should know is 2 to the third. Alright, and I can see that the 8's are going to cancel out. So there's powers of 2 that cancel out. An x is going to cancel out, a y is going to cancel out, and 1z. And anything that's uncircled, right, is left, that's going to be 3y squared over 5z squared. And that's going to be my answer that's not there. Ta-da! Alright, 3y squared over 5z squared. want you to pause it and give this a try and unpause when you think you've got an answer. Thank you. Okay, here's the factorization of the 2. So I've written it out. And then I'm just going to go ahead and cross out common primes, which would be the 5, 1x, 1y. Whatever's left, 3 times 3 are 9x in the top. And in the bottom, 19y squared. Okay, so this is one good use for LCM. For least common multiple, right? Well, here's one way. So if we have two equal ratios, two fractions that are equal, we call that a proportion. And the way that we probably have solved proportions at this point is by cross product. So that would be method 1, a method that we've kind of used before, where I'm going to take the denominators and multiply them by the opposite numerators to get equal equal parts. So if I get 15 times 3x is 45x, and the 10 times 2x was 2, because it's a monomial, or binomial rather, up here, make sure you distribute. And then go ahead and solve, subtract the 20, get the VOSO, get the variables on one side only. Solve by dividing by 25 to both sides. And x is going to equal 20 over 25. They got a common factor of 5. Going to leave me with 4/5. And that's certainly a good method. Another method, method 2, right, we're going to indicate as method 2, is if I take the same problem, but instead of multiplying by cross products, I'm going to multiply both sides by whatever the LCM is. And so if I either think or do the factorization of the denominator, I see that they share a 5. So the LCM would be either 10 times 3, which is 30, or 15, this number, times the leftover 2, which is 30. So I'm going to multiply both sides by 30. And what that will do, since both 10 and 15 are factors of 30 to be the LCM, the denominators will cancel out and leave me with 3 times 3x, or 9x, equals 2 times 2x plus 2, which becomes 4x plus 4. That's really the same problem, but what ends up happening is my numbers end up being a little bit more manageable and easier than if I just do straight cross products. So I want you to go ahead and solve this one by either method, whatever one you choose to do. And then come back once you're done. Okay, so over here, method 1, I've done cross products to get 40x minus 20 equals 30x. Then solved, I got x equals 2. Here I multiplied by the LCM, which was 10. And then the nice thing was, when I multiplied by 10, the denominators canceled. Everything canceled over here, so it left me with 6x. And the 5 and the 10 canceled, so all I had to do is distribute a 2, that green 2 in there, to get 8x minus 4. And solving that was pretty easy. Alright, that's all we have so far for the application for GCF and LCM. And I have another short video on exponent rules within this unit. Namaste.